Right now, as you read this, a version of you from 10 years ago is still sitting somewhere, doing exactly what they were doing then. And a version of you decades from now already exists, frozen in a moment you have not yet lived. According to a serious interpretation of modern physics, every instant of your life is permanent and equally real. Nothing is ever truly gone, and nothing is genuinely yet to come. This claim sounds impossible. Our entire experience tells us otherwise. We feel the present slipping away with every heartbeat. We remember a past that seems finished, and face a future that seems open and undecided. The sensation of time moving forward is perhaps the most basic fact of being alive. Yet some of the most respected physicists and philosophers argue that this sensation is misleading. Their reasoning does not come from imagination. It comes from Einstein's theory of relativity, a framework so well confirmed that the satellites guiding your phone depend on it to function. When you take that theory seriously and follow its logic all the way to the end, the neat division of time into past, present, and future begins to break apart. What replaces it is a picture in which all moments coexist within a single fixed structure. That structure has a name. Physicists call it the block universe. In what follows, we will trace how this idea arose, why it troubles so many people, and what it would mean if it turned out to be true. We will move carefully from familiar ground toward the strangest implications and examine what survives scrutiny and what does not. Consider what happens in the smallest unit of your experience. You are reading these words, and the moment you finish this sentence already feels different from the moment you began it. Something has shifted. The earlier instant has receded into memory, and a new instant has taken its place. This is the texture of ordinary life, so constant and so familiar that we rarely stop to notice it. Time, for us, is not a static thing to be examined from the outside. It is a current we are caught in, always carrying us forward, never pausing, never reversing. We speak of it slipping through our fingers, of it flying when we are absorbed and dragging when we are bored. But in every case, we treat it as something in motion. The present is where we live. The past is the territory we have already crossed, sealed and unchangeable. The future is the open country ahead, not yet arrived, full of possibilities that have not yet been settled. This division feels less like a belief and more like a direct perception, as obvious as the solidity of the ground or the brightness of the sun, and it shapes everything about how we think and act. We make plans because we believe the future is open and can be influenced. We feel regret because we believe the past is fixed and beyond our reach. We savor good moments because we believe they will pass, and we endure painful ones for the same reason. Our emotional life, our morality, our entire sense of what it means to be a person rests on the conviction that time flows and that the present moment holds a special status the other moments lack. The now is real in a way that yesterday and tomorrow are not. Yesterday was real once, but has lost that status. Tomorrow may become real, but has not earned it yet. Only the present instant carries the full weight of existence. Philosophers have a name for this intuition. They call it presentism, the view that only the present is real, and that the past and future are not places that exist somewhere, but simply ways of describing what no longer is and what is not yet. It is the most natural position imaginable, the one almost every human being holds without ever being taught it. A child grasps the difference between now and later long before they can articulate it. Every language on Earth marks tense, dividing events into what was, what is, and what will be. The flow of time seems woven into the very structure of thought, so deep that imagining its absence feels almost like imagining the absence of space or self. Yet when we try to pin down exactly what this flow is, the certainty begins to dissolve. Ask a simple question. How fast does time pass? The natural answer is that 1 second passes every second, but a moment's reflection shows this is empty. To say time moves at 1 second per second is to compare time to itself, which tells us nothing. When we say a car moves at a certain speed, we measure its position against the passing of time. But when we try to measure the speed of time, we have nothing external to measure it against. There is no second clock standing outside of time, against which the flow of the first could be gauged. The motion of time, if it is motion at all, is unlike any other motion we know, because it lacks the very thing that gives motion meaning. This is the first crack in an idea that seemed unbreakable. If time flows, it should flow with respect to something, and there is nothing for it to flow with respect to. Push a little further, and the puzzles multiply. We say the present moves into the future, but a moment must move with respect to time, and the present is itself a moment of time. So the present would have to move with respect to time, which is to say with respect to a sequence of presents, which simply restates the problem in different words. The flow of time, examined closely, seems to chase its own tail, defined in terms of the very thing it is supposed to explain. Then there is the question of the present's special status. We feel that now is privileged, that it alone is fully real. But which now? The now in which you read this sentence will, in an instant, be the past. And the now that follows it will claim the same privilege, only to surrender it just as quickly. Every moment, in its turn, regards itself as the present, the one true now, and every moment is equally justified in doing so. From the perspective of any given instant, that instant is the center of reality. There is no moment that is objectively the present in a way that singles it out from all the rest. The present, it turns out, is not a fixed location, but a label that every moment applies to itself. This is precisely how we describe space. There is no place that is objectively here. Every location is here to whoever stands in it, and there to everyone else. We long ago accepted that here is a matter of perspective, not a special property woven into a particular patch of ground. The unsettling suggestion is that now might be exactly the same kind of thing, a perspective rather than a property, a label rather than a privileged status that some single moment genuinely possesses. These are the questions philosophers have wrestled with for over 2,000 years. And for most of that history they remained purely philosophical, arguments traded back and forth, with no way to settle them. The ancient Greeks felt the difficulty acutely. Heraclitus insisted that everything flows, that you cannot step into the same river twice, that change and becoming are the deepest truths of reality. Against him stood Parmenides, who argued through pure reason that change is impossible and illusory, that reality is a single unchanging whole, and that the appearance of flow is a deception of the senses. Their disagreement was, in essence, the very disagreement we are tracing now, between a world that genuinely becomes and a world that simply is. For 2.5 millennia, the question seemed to belong entirely to metaphysics, the kind of debate that could never be resolved by observation, because it concerned the nature of time itself, rather than any particular event within time. What changed everything was an unexpected development. The question stopped being purely philosophical and became, at least in part, a question of physics. The flow of time, which had seemed forever beyond the reach of measurement and experiment, turned out to have consequences that could be tested. And when physicists built theories precise enough to describe how time actually behaves, those theories began to deliver verdicts on the ancient debate. The verdicts were not what most people would have predicted. They did not confirm the obvious truth that time flows. Instead, they pointed, slowly and with mounting force, toward the strange conclusion that the flow of time may be no part of physical reality at all. But before we can understand how physics arrived at such a conclusion, we have to understand the picture of time that physics began with. For roughly 2 centuries, science held a view of time that matched our everyday intuition almost perfectly. A view so successful and so natural that questioning it would have seemed absurd. It was a picture of time as something absolute, universal, and utterly reliable. A single cosmic rhythm beating in unison throughout all of creation. To see how that picture was eventually overturned, we first need to see how completely it once dominated, and why the greatest mind of the early scientific age was so certain it was correct. The man who gave time its first rigorous scientific form was Isaac Newton, and the picture he constructed was as confident as it was sweeping. In the late 17th century, when Newton was assembling the mathematical framework that would govern physics for the next 200 years, he needed a stage on which his moving bodies could act. Planets had to orbit, apples had to fall, cannonballs had to arc through the air, and all of these motions had to be measured against something stable and dependable. Newton found that stability in 2 concepts he treated as the unquestioned backdrop of everything. The first was absolute space, an infinite, motionless container in which all objects sat and moved. The second was absolute time, and it is the second that concerns us here. Newton wrote that absolute time, of itself and by its own nature, flows uniformly without regard to anything external. The phrasing is worth pausing on. Time, for Newton, was a thing in its own right, independent of events, independent of matter, independent of any observer. It would continue to flow at the same steady rate, whether the universe were full of activity or completely empty. He imagined it as a kind of cosmic clock, ticking away in the background of reality, its rhythm identical at every point in the cosmos. 1 second here was precisely 1 second on the far side of the galaxy, and the 2 seconds began and ended together, perfectly synchronized across infinite distance. There was a single universal now that swept across all of space at once, dividing the entire universe cleanly into what had already happened and what was yet to come. This was the mathematical enshrinement of presentism, the ordinary human intuition raised to the status of physical law, and it worked extraordinarily well. With absolute time as his foundation, Newton wrote down laws of motion and a law of gravitation that explained the orbits of the planets, the timing of the tides, the trajectory of comets, and the fall of objects on Earth, all within a single unified scheme. The precision was breathtaking. Astronomers could predict eclipses years in advance, calculate the return of comets across decades, and chart the positions of planets with an accuracy that left no room for doubt. The success of Newtonian physics was so total that it came to seem less like one possible description of nature and more like a direct readout of how the universe truly was. And embedded at the very heart of that description was the assumption of a single, shared, absolute time. Within Newton's framework, the flow of time and the universal present were simply given. They did not need to be explained or justified. They were the canvas on which the physics was painted. Every event in the universe carried an unambiguous time stamp, a definite moment at which it occurred, and any two events could be compared without ambiguity. Either they happened at the same time, or one happened before the other, and every observer everywhere would agree on the answer. The notion that two competent observers might genuinely disagree about whether two events were simultaneous would have struck Newton as not merely false, but incoherent, a contradiction in terms. Simultaneity was absolute because time itself was absolute. The cosmic clock ticked once, and its tick reached every corner of existence in the same instant. It is important to appreciate how reasonable this all was, because it is easy, looking back, to treat Newton's assumptions as a mistake waiting to be corrected. They were nothing of the kind. They matched every observation available at the time. They matched, and still match, the everyday experience of every human being who has ever lived. When you and a friend agree to meet at noon, you are relying on Newtonian time without a second thought. You assume that noon for you is noon for them, that the present moment you share is genuinely shared, that the clock on the wall and the clock in their pocket are measuring the same flowing river of time. In ordinary life, this assumption never fails. It never even comes close to failing. The reason is that the effects which eventually overturned it are so small at everyday speeds that no one could possibly notice them without instruments of extraordinary precision. Newton's time was not wrong for the world he could observe. It was an essentially perfect description of that world. Its limitations lay hidden in regimes of nature that the 17th century had no means of reaching, in the behavior of objects moving at speeds close to that of light. Still, even at the height of its success, the Newtonian picture carried a quiet philosophical tension that a few careful thinkers noticed. If absolute time flows uniformly without regard to anything external, then it flows even in a completely empty universe, even with no clocks, no events, no change of any kind to mark its passage. But what could the flow of time possibly mean in a universe where nothing ever happens? How could time be passing if there were no events to be ordered, no before and after to distinguish? The great philosopher Gottfried Leibniz, Newton's contemporary and rival, pressed exactly this objection. He argued that time was not a thing in itself, but merely the order of events, the relation of before and after among things that actually happen. Take away the events, Leibniz insisted, and you take away time. There was no invisible river flowing in the background, only the sequence of occurrences and the relations between them. The debate between Newton's absolute time and Leibniz's relational time was never fully resolved in their lifetimes, and it would echo through physics for centuries, eventually resurfacing in a form neither man could have anticipated. For the moment, though, Newton's view prevailed, and it prevailed almost completely. Through the 18th and 19th centuries, as physics expanded into new domains, the assumption of absolute time remained firmly in place. When scientists studied heat, electricity, magnetism, and the behavior of gases, they did so against the backdrop of a universal clock that no one thought to question. Time was the one thing every theory could rely on without examination. It was the bedrock beneath the bedrock, so fundamental that it disappeared from view, the way the assumptions we hold most deeply tend to become invisible, precisely because we never think to look at them. And yet, in the 19th century, a body of work was quietly accumulating that would eventually shatter the entire edifice. It came not from the study of time itself, but from the study of something that seemed, on the surface, completely unrelated. It came from the study of light. Physicists were learning to describe light as a wave, an electromagnetic disturbance rippling through space, and their equations carried within them a number that would prove to be a kind of buried explosive. That number was the speed of light, and the equations insisted on it with a peculiar stubbornness. The speed of light was not just a measured quantity. It appeared in the fundamental laws of electromagnetism as a fixed constant, a feature of the universe itself, the same in every direction and seemingly independent of who was doing the measuring. This created a problem that grew sharper the more closely physicists examined it. According to Newtonian thinking, speeds should add and subtract in a simple, intuitive way. If you walk forward on a moving train, your speed relative to the ground is the train's speed plus your walking speed. If you shine a light forward from a moving vehicle, the light should travel at its usual speed, plus the speed of the vehicle. That was the obvious expectation, the one demanded by absolute space and absolute time. But the equations of electromagnetism suggested otherwise. They suggested that light always travels at the same speed, regardless of the motion of its source. And when experimenters tried to detect the variations that Newtonian physics predicted, the variations refused to appear. The most famous of these experiments, conducted in the late 19th century, was designed to measure how the Earth's motion through space affected the speed of light. It was a careful, sensitive, beautifully executed experiment, and it found nothing. The speed of light came out the same, no matter how the Earth was moving. This was a genuine crisis, even if its full depth was not immediately appreciated. The most successful framework in the history of science, Newton's, predicted one thing: the equations governing light, equally successful in their own domain, predicted another. And the experiment sided with light. Something at the foundation had to give way. For years, physicists tried to patch the problem with various adjustments, proposing that objects physically contracted as they moved, or that the medium light traveled through dragged along with matter in just the right way to hide the effect. These efforts grew increasingly strained, a collection of separate fixes each invented to plug a particular leak. What was missing was a single insight that could explain why light behaved as it did, an insight willing to question the one assumption that no one had thought to question. The assumption was absolute time itself, and the person who finally dared to question it would, in doing so, begin the long process of dismantling the flowing river of time that Newton had built his universe upon. The person who questioned absolute time was a young patent clerk in Bern, Switzerland, who in 1905 had no academic position, no laboratory, and no obvious standing to overturn 2 centuries of physics. Albert Einstein approached the crisis surrounding light from a direction no one else had fully pursued. Where others treated the constancy of light's speed as a problem to be explained away, Einstein took it as a starting point to be accepted. He asked a deceptively simple question: what would the universe have to be like for the speed of light to genuinely be the same for every observer, regardless of how they were moving? The answer he arrived at was breathtaking in its boldness, because the only way to keep the speed of light constant for everyone was to give up the idea that time was the same for everyone. To grasp why, consider what speed actually is. Speed is distance divided by time. It is a measurement that combines a stretch of space with a duration. If the speed of light must remain fixed for all observers, but different observers are moving differently relative to the light, then something about their measurements of distance and time must adjust to compensate. The numbers have to bend so that the ratio always comes out the same. Einstein realized that if the speed of light could not change, then space and time themselves would have to change instead. They would have to stretch and compress, depending on the motion of the observer, in precisely the way needed to hold the speed of light constant. Distance and duration, which Newton had treated as absolute and unchanging, became flexible. They became quantities that different observers would measure differently, with no single correct answer. This was the birth of special relativity, and its consequences unfolded with relentless logic from that single principle. The first casualty was the idea that moving clocks tick at the same rate as stationary ones. According to relativity, a clock in motion relative to you runs slow. The faster it moves, the slower it ticks from your point of view. This is not an illusion or a mechanical defect. It is time itself, running at a different rate for the moving clock. The effect is called time dilation, and it sounds like pure fantasy until you confront the evidence. Particles called muons, created high in the atmosphere when cosmic rays strike it, decay so quickly that they should never survive the journey to the ground. Yet they arrive in large numbers. The reason is that they move at nearly the speed of light, and from our perspective, their internal clocks run slow, stretching their brief lifetimes just enough to complete the trip. Atomic clocks flown on aircraft return, showing slightly less elapsed time than identical clocks left on the ground. The satellites of the Global Positioning System must correct for these effects continuously, because the clocks aboard them, moving rapidly in orbit, tick at a measurably different rate than clocks on the surface. Without these corrections, the navigation systems millions of people rely on every day would drift into uselessness within hours. Time dilation is not a theoretical curiosity. It is a daily engineering reality. Alongside time dilation came its spatial counterpart. Objects in motion are measured to be shortened along their direction of travel. A spaceship rushing past you at high speed would be measured as compressed, squeezed thinner than it would be at rest. Space, like time, turned out to be elastic, and crucially, the two effects were linked. The stretching of time and the contraction of space were two aspects of a single underlying adjustment, coordinated so precisely that the speed of light always emerged unchanged. Einstein had taken the rigid scaffolding of Newton's universe, the fixed grid of absolute space, and the steady beat of absolute time, and shown that it was not rigid at all. It flexed, it depended on motion, and no observer's measurements were any more correct than any others. But the deepest blow, the one that strikes directly at the flow of time and the universal present, concerns simultaneity. This is the heart of the matter, and it deserves careful attention, because it is the point at which the whole edifice of presentism begins to crack. Recall what Newton assumed. Two events either happen at the same time, or they do not, and every observer agrees. The universal now sweeps across all of space, dividing existence cleanly into past and future at every instant. Einstein showed that this is false. Whether two separated events are simultaneous depends on the motion of the observer. Two events that one observer judges to happen at the same moment will be judged by another observer moving differently to happen at different moments. And there is no fact of the matter about which one is right, because in relativity, all uniformly moving observers are equally valid. Simultaneity is not absolute. It is relative. There is no single universal now. To see how this follows, imagine a classic scenario. A long train moves down a track at high speed, and at the exact center of one car stands an observer. At the front and back of the car are two lamps. Now suppose that, from the point of view of someone standing on the platform, watching the train pass, the two lamps flash at precisely the same instant. The light from each flash travels toward the center of the car at the fixed speed of light. The observer on the platform sees the flashes happen simultaneously and sees their light reach the center observer at the same moment, because the platform observer sees the center observer staying put as the light converges. But consider the situation from the perspective of the observer inside the train. During the time it takes the light to travel from the lamps to the center, the train has moved forward. The observer at the center is moving toward the light coming from the front lamp, and away from the light coming from the back lamp. Since the speed of light is the same in both directions for this observer too, and since the light from the front had less distance to cover relative to the moving observer, while the light from the back had more, the light from the front lamp reaches the center observer first. From inside the train, the front lamp flashed before the back lamp. Here is the crucial point. Both observers are correct. There is no error in either account. The platform observer genuinely sees the flashes as simultaneous. The train observer genuinely sees them as occurring one after the other. Relativity insists that neither perspective is privileged, that both are equally valid descriptions of reality. And so the question of whether the two flashes happened at the same time has no single answer. It depends entirely on who is asking and how they are moving. Simultaneity, the very notion that allowed Newton to define a universal present, dissolves into a matter of perspective. The implications ripple outward immediately. If different observers disagree about which events are simultaneous, then they disagree about what counts as happening now. And if they disagree about what is happening now, they disagree about what belongs to the present, what has already passed into the fixed past, and what still lies in the open future. The neat universal division of time into past, present, and future, identical for everyone, simply cannot survive. Each observer carries their own now, their own slice of simultaneous events, and these slices tilt and shift depending on motion. For one observer, a distant event might lie in the present. For another, moving differently, that very same event might already be in the past. For a third, it might still be in the future. All three are equally entitled to their judgment, because relativity grants no observer a privileged position from which to declare the true present. This is where the trouble for our ordinary picture of time becomes acute. We are deeply attached to the idea that there is a real, objective present, a now that is genuinely happening throughout the universe at this very instant. We imagine that as you read this, somewhere across the galaxy, events are unfolding now, in the same present moment you occupy. Relativity tells us this idea has no clear meaning. There is no fact about what is happening now on a distant world, because now is not a universal thing. It is relative to motion. Change your speed, even slightly, and your now tilts, sweeping across distant regions of space to include different events. The present, which felt like the most solid and shared aspect of reality, turns out to be a personal and shifting thing, different for every differently moving observer, with no master clock to adjudicate among them. It is worth dwelling on how thoroughly this overturns the assumption that lay beneath all of classical physics and beneath ordinary human experience. Newton's universal clock is gone. There is no single tick that reaches all of space at once. Instead, there are as many nows as there are states of motion, each equally real, each slicing the universe of events at a slightly different angle. The river of time, which seemed to flow in one direction, at one rate for everyone, fractures into countless rivers flowing at different rates, each observer carried along their own. And once you accept that there is no shared present, a deeper question presses forward, one that Einstein himself did not initially emphasize, but that his former teacher would soon make impossible to avoid. If every observer's present is just one slice among many equally valid slices, and if all these slices together must somehow be consistent with one another, then what is the complete structure that contains them all? What does the universe look like when you stop privileging any single now and instead consider every event, past, present, and future, on equal terms? The answer would transform relativity from a theory about measurement into a theory about the very architecture of existence, and it would point unmistakably toward a universe in which all of time exists at once. The man who supplied that answer was Hermann Minkowski, a mathematician who had once taught Einstein at the Zurich Polytechnic, and had not, by his own admission, been especially impressed by the young man's diligence as a student. In 1908, 3 years after Einstein published Special Relativity, Minkowski delivered a lecture that reframed the entire theory in a way Einstein had not originally intended. He opened with a declaration that has become one of the most quoted statements in the history of physics. He announced that from then on, space by itself and time by itself were destined to fade into mere shadows, and only a kind of union of the two would preserve an independent reality. What Minkowski had recognized was that the strange, flexible behavior of space and time in relativity was not really telling us that space and time were each unreliable. It was telling us that space and time were not separate things at all. They were two aspects of a single, deeper entity, and that entity was perfectly stable, perfectly absolute, in a way that space and time individually were not. To understand the insight, consider what relativity had actually shown. Different observers disagree about durations because moving clocks run slow. Different observers disagree about distances because moving objects are contracted. Different observers even disagree about simultaneity, about which events happen at the same time. Everything that Newton had treated as absolute seemed to have dissolved into a haze of differing perspectives. But Minkowski noticed something remarkable hidden within the disagreements. Although observers disagreed about distances in space and intervals in time taken separately, there was a particular combination of the two that every observer agreed upon. When you took the spatial separation between two events and the temporal separation between them and combined them in a specific way, the result came out identical for all observers, no matter how they were moving. This combined quantity was called the spacetime interval, and it was the true invariant, the genuinely absolute measure that survived the relativity of space and time. The lesson was profound. Space and time are like the shadow that a single object casts on two different walls. Imagine holding a pencil and shining a light on it so that it casts a shadow on the floor, and another on the wall. As you rotate the pencil, the length of its shadow on the floor changes, and so does the length of its shadow on the wall. An observer who could only see the floor shadow and another who could only see the wall shadow would disagree about how long the pencil is, and each measurement would change as the pencil turned. But the pencil itself never changes length. Its true length is fixed. The shifting shadows are merely projections of an unchanging object onto two different surfaces. Minkowski proposed that space and time are exactly like those two shadows. What we call a distance in space and a duration in time are projections onto our particular perspective of a single underlying structure that does not change at all. Different observers, moving differently, are like observers viewing the pencil from different angles, each seeing different shadows, each disagreeing about the projections, while the underlying reality remains one and the same. Changing your motion is like rotating your perspective within this deeper structure, trading some space for some time for some space, in a way that always preserves the true interval. That deeper structure is space-time, a four-dimensional fusion of the three familiar dimensions of space with the one dimension of time. And here the picture begins to acquire its full and startling character. In ordinary thinking, space is a thing that exists all at once, laid out in every direction, while time is something that flows, that passes, that comes into being moment by moment. We treat the two completely differently. Space is a place, time is a process. But Minkowski's reformulation treats them on equal footing, as dimensions of a single geometric object. And in geometry, nothing flows. A line does not grow as you trace along it. A surface does not come into being as your finger sweeps across it. The whole shape simply exists, all of its parts equally present, and your finger moving across it adds nothing to the shape itself. It merely picks out one location after another in something that was already complete. If time is truly a dimension of space-time, in the same sense that the three spatial dimensions are dimensions of space, then time does not flow any more than space flows. The entire four-dimensional structure simply is, laid out in full, with every event at its proper location, and nothing about it coming into being or passing away. This is the block universe in its mature mathematical form. Picture the history of the entire cosmos not as a sequence of moments succeeding one another, but as a single fixed object existing in four dimensions. Every event that has ever happened or ever will happen occupies a definite point in this structure. The moment of your birth is a location within it. This present instant is another location. The final moment of your life is another still, already there, already real, sitting at its appointed place in the block. Your entire life is not a movie playing out frame by frame, but a single unchanging shape, a long winding thread running through the four-dimensional landscape, every part of it equally existent. The same is true of every person, every star, every particle. The cosmos, viewed this way, is a completed structure, motionless and eternal, containing all of time within itself. In this picture, the path each object traces through space-time has a name. It is called a world line. Your world line is the complete trajectory of your existence through the four dimensions, beginning at your birth and ending at your death, threading through every location you have ever occupied at every moment you have occupied it. A planet orbiting its star traces a long helix, a spiral winding through space-time as it circles again and again while moving forward in time. A photon of light traces a straight line at the characteristic angle that its speed dictates. Everything that exists is, in this view, a world line or a bundle of world lines, a fixed feature of the block, neither growing nor shrinking nor moving, because there is no external time in which such change could occur. The block universe does not evolve. It is not going anywhere. It contains all the going within itself as a static pattern. What then becomes of our overwhelming sense that time passes, that the present moves, that we are carried forward from moment to moment? In the block universe, this sense must be understood as something internal to the structure, rather than a feature of the structure as a whole. Consider your world line again, that thread running through the 4 dimensions. At every point along it, there is a version of you, with a brain in a particular state, holding particular memories. The version of you at the location labeled this morning has memories of last night, but none of this afternoon. The version of you at the location labeled this afternoon has memories of this morning, including memories of having looked forward to the afternoon. Each momentary version of you, at each point along the world line, finds itself equipped with memories of the earlier points and no knowledge of the later ones. Each one therefore experiences itself as the present, poised between a remembered past and an unknown future. The flow of time, in this account, is not the structure changing. It is the way the structure feels from the inside, at each of the countless points along your world line, every one of which regards itself as now. The movie is not playing. Every frame simply exists, and in every frame there is a you who remembers the previous frames, and so believes the movie is in motion. This is a genuinely difficult idea to hold in the mind, because it asks us to step outside the very perspective from which we do all our thinking. We are always located at some now, always experiencing the flow, and to imagine the block as a whole is to imagine a viewpoint that no living being ever actually occupies, a view from outside time, sometimes called the view from nowhere or the God's eye view. From that imagined vantage, there is no special present, no flowing, no becoming. There is only the eternal 4-dimensional landscape, with all its events arrayed in their fixed positions. The philosopher who first articulated this distinction with full clarity spoke of 2 ways of describing time, one that uses past, present, and future, and another that uses only the relations of earlier, than, and later than. The first way builds in the flow and the privileged present. The second way describes only the fixed ordering of events, the way the points along a line are ordered without any of them being singled out as the location you happen to be at. Relativity and the block universe, taken together, suggest that the second description captures everything that is physically real, and that the first description, with its moving now, adds nothing to the physics and reflects only our particular way of being embedded in the structure. It would be easy to dismiss all of this as mathematical abstraction, an elegant way of bookkeeping that need not be taken as a literal claim about reality. Perhaps spacetime is just a convenient calculating device, and time really does flow despite the equations. Many people's first instinct is to retreat to this position, but the difficulty is that the geometry of spacetime is not an optional reinterpretation. It is the most natural and economical way to express what relativity has been confirmed over and over to be true. The invariance of the spacetime interval is a measured fact. The relativity of simultaneity is a measured fact. The behavior of moving clocks and contracting lengths follows precisely from treating spacetime as a unified geometric whole. To insist that time nonetheless flows, on top of all this, is to add a feature that the physics does not require and cannot detect, a metaphysical extra bolted onto a theory that works perfectly well without it. And once we take the geometry seriously, as the physics seems to demand, we are led toward the conclusion that the space-time interval describes that all events coexist within a single fixed structure, and that the distinction between what has happened and what will happen is not built into reality, but into our point of view. Yet even granting all of this, a sharp objection remains, one that asks whether we can really speak of distant events as already existing. And it is to that objection, and the surprising argument that answers it, that the reasoning must now turn. The objection runs like this. Granting that simultaneity is relative, granting that different observers slice space-time at different angles, does any of this actually prove that the future already exists? Perhaps each observer's present is genuinely real for them, the past genuinely fixed, the future genuinely open, and the disagreements between observers are just disagreements about labeling, with no deep consequence for what truly exists. One might hold that reality is still a flowing present that becomes, and that relativity merely complicates how different observers describe that flow without abolishing it. This is a reasonable place to dig in, and for decades it seemed like a possible refuge. But in the late 1960s, two philosophers working independently and arriving at essentially the same conclusion constructed an argument that turned the relativity of simultaneity into a direct case for the reality of the future. The argument is known by their names, Ritdijk and Putnam, and it is one of the sharpest weapons in the case for the block universe. The argument proceeds in careful steps, and its power lies in how few assumptions it needs. Begin with a principle that seems almost impossible to deny. If two events are simultaneous for some observer, and that observer is a legitimate, uniformly moving observer, no different in standing from any other, then both events must be equally real. Whatever is happening in your present moment, right now, is real. This seems beyond dispute. The events in your present are not maybes or projections. They are actual, existing occurrences. Call this the reality of the present. Now add the lesson of relativity. What counts as the present, as the set of simultaneous events, depends on the observer's motion. Two observers passing each other at the same point in space, but moving differently, will have different planes of simultaneity, different sets of events that each considers to be happening now. And by the principle just stated, each observer's present is fully real. Now watch how these combine. Suppose you are sitting still, and your plane of present includes a certain distant event, far across space, that you judge to be happening at this moment. By the reality of the present, that distant event is real. Now suppose a second observer walks past you, moving at a modest speed in the direction of that distant event. Because of the relativity of simultaneity, this walking observer's plane of present is tilted relative to yours. For events very far away, even a small tilt sweeps across an enormous span of time, because the plane is tilted across a vast distance. The result is that the walking observer's present, out at that distant location, does not coincide with yours. It includes events that, from your perspective, lie in the future. And by the same principle of the reality of the present, those events are real for the walking observer. Here, the chain tightens. You and the walking observer are at the same place at the same moment. You are looking at each other, sharing the same point in spacetime. Yet the walking observer's present includes a distant event that lies in your future. If that observer's present is real, then the distant future event, real for them, must be real in an absolute sense, because reality cannot depend on something as arbitrary as walking speed. An event cannot be real for the person strolling past you, and unreal for you sitting still, when the two of you occupy the same point of space and time. Reality is not the kind of thing that flickers in and out, depending on how fast someone happens to be walking. So if the event is real for the walking observer, it is real, full stop, and it lies in your future. Therefore, your future is already real. The argument can then be run again from the walking observer's perspective, and from any number of differently moving observers, weaving together a network of presence that collectively guarantees the reality of events stretching arbitrarily far into the future and the past. The conclusion is that all events, regardless of whether we call them past, present, or future, are equally real. The block universe is not just a convenient geometry. It is forced upon us by combining relativity with the simple idea that what is present is real, and that reality does not depend on one state of motion. The elegance of this argument is matched by how deeply unsettling its conclusion is, and it has been the subject of intense debate ever since. Critics have probed every joint. Some have questioned whether reality should be treated as the kind of thing that can be transferred from one observer's present to another's in the way the argument requires. Perhaps, they suggest, reality is itself relative, so that an event can be real relative to one observer and not yet real relative to another, with no contradiction. But this move comes at a steep price. It abandons the idea that there is a single, observer-independent fact about what exists, replacing it with a fractured reality that differs from frame to frame. Most philosophers find that cure as troubling as the disease, because it seems to make existence itself a matter of perspective in a way that strains comprehension. Others have argued that the argument illegitimately treats the distant event as already determinate when it might still be genuinely open. But the force of relativity is precisely that there is no privileged frame in which to say the event is not yet determinate. Every attempt to rescue an open future seems to require smuggling back in exactly the kind of absolute present that relativity has shown does not exist. It helps to make the abstract concrete with the scale of the effect, because the tilting of the planes of simultaneity sounds small until you appreciate how distance amplifies it. The amount by which your present and the walking observer's present diverge at a distant location grows with that distance. Over the span of a room, the divergence is utterly negligible, far too small to notice or measure. But space is vast. Over the distance to a star many light years away, a difference in motion of only a few kilometers per hour, the pace of a casual walk can shift the planes of simultaneity by minutes, by hours, by days, at sufficient distances. The faster the motion and the greater the distance, the larger the shift. For events across the gulfs that separate galaxies, an ordinary difference in velocity translates into a divergence of years or centuries in what each observer calls the present. The geometry that is invisible in a room becomes dramatic on the scale of the cosmos. This is why the argument has such reach. It does not depend on exotic speeds or extreme conditions. The everyday fact that people walk in different directions at different speeds, combined with the immense distances of space, is enough to entangle vast stretches of what we would call past and future into the network of equally real events. There is a way of visualizing this that brings the strangeness into focus. Imagine the universe as a loaf of bread, with all of space at one instant being a single thin slice. Newton would have said there is one correct way to slice the loaf, one true set of parallel cuts dividing it into a definite sequence of present moments, the same for everyone. Relativity says there is no single correct way to slice it. Different observers slice the loaf at different angles, and every angle is as valid as any other. The loaf, the full four-dimensional block, is what truly exists. The slices are just different ways of carving it up into successive presents, and the carving reflects the observer rather than the bread. Once you accept that the loaf itself is the reality, and the slices are merely perspectives upon it, the conclusion of the Rietvdijk and Putnam argument follows almost without effort. The whole loaf is there. Every slice, at every angle, cuts through events that are all equally part of the existing bread. The future slices and the past slices are not different in their reality from the present slice. They are simply other regions of the same loaf, and which regions you call present depends only on the angle of your particular cut. This image, the loaf and its slices, captures both the appeal and the discomfort of the block universe. The appeal is that it makes sense of relativity with perfect coherence, requiring no privileged present, no mysterious flow, no master clock. The discomfort is that it seems to drain the future of its openness, to make tomorrow as fixed and finished as yesterday, to reduce our sense of an unfolding life to a kind of illusion generated by our position within the loaf. And yet, the argument that leads here is not built from speculation. It is built from relativity, which is among the most rigorously confirmed theories we possess, combined with assumptions about reality that are difficult to reject without paying a heavy price. The case is serious, and it cannot be waved away as mere philosophy detached from physics. But the argument also points toward a further question, one that becomes pressing the moment we accept that distant events are entangled with our own present in this way. If observers passing each other can sweep their planes of simultaneity across years of distant time, then the structure of cause and effect, of what can influence what, must impose its own constraints on this picture. Reality may be a single loaf, but not every part of it can reach every other part. There are limits set by the speed of light that carve the block into distinct regions, and understanding those regions reveals both how the block protects us from outright contradiction and how it shapes what the future can possibly mean. The constraint that organizes the entire block, the feature that keeps it from collapsing into contradiction, is the speed of light. In relativity, the speed of light is not merely the speed at which light happens to travel. It is the absolute upper limit on the speed of any influence, any signal, any cause reaching forward to produce an effect. Nothing carrying information or energy can exceed it. This limit, which might seem like a mere restriction on fast travel, turns out to impose a deep and beautiful structure on space-time, dividing the regions around any event into distinct zones with sharply different relationships to that event. The structure is called the light cone, and it is the key to understanding how causality lives within the block universe. Picture any single event, a flash of light at a particular point in space and a particular moment in time. Call it here and now. From that flash, light spreads outward in all directions, expanding as a sphere that grows larger with each passing instant. If we represent this in a diagram, suppressing one dimension of space so we can draw it. The expanding sphere of light traces out a cone opening upward into the future. This is the future light cone. It contains every event that the flash could possibly reach, every point in space-time that a signal from the flash, traveling at or below the speed of light, could influence. Anything inside this future cone is a place the flash can affect. Anything outside it is forever beyond the flash's reach, because reaching it would require sending an influence faster than light, which is impossible. The cone marks the absolute boundary of causal influence, extending forward in time. There is a mirror image extending in the other direction. Below the event, opening downward into the past, lies the past light cone. It contains every event that could have sent a signal reaching the here and now. Every point in space-time whose influence could have arrived in time to affect the flash. Everything you can see, everything that can have shaped your present circumstances, every cause that could have contributed to this moment, lies within your past light cone. The light arriving at your eyes right now left distant stars years or centuries ago, traveling along the surface of your past light cone to reach you. When you look at the night sky, you are not seeing the stars as they are now. You are seeing the past, the light that left them long ago, arriving along the boundary of your backward cone. The past light cone is the complete record of everything that could possibly bear on your present. Between these two cones, the future opening upward and the past opening downward, lies a vast region that belongs to neither. These are the events that are too far away in space to have either influenced the here and now, or to be influenced by it, given the light speed limit. An event that happens at this instant on a planet many light years away falls into this in-between region. No signal from it has had time to reach us, and no signal from us could reach it in time to matter to its present. This region is sometimes called the elsewhere, or the region of space-like separation. It is the part of space-time that is causally disconnected from the here and now, neither cause nor effect, neither reachable nor reaching. And it is precisely this region that the relativity of simultaneity governs. The events that different observers disagree about, the distant occurrences that one observer places in the present and another in the past or future, all lie in this causally disconnected elsewhere. This is not a coincidence. It is the structure that prevents the block universe from generating paradoxes. Consider why this matters. The Rietvdijk and Putnam argument showed that observers passing each other can sweep their planes of simultaneity across distant events, making the future of one observer the present of another. If this could happen for events that are causally connected, the consequences would be catastrophic. You could, in principle, receive information about your own future or influence your own past, opening the door to contradictions in which an effect undoes its own cause. But the light cone structure forbids exactly this. The events whose status as past, present, or future depends on the observer's motion are always the causally disconnected ones, the events in the elsewhere. For any two events that are causally connected, that lie within each other's light cones, all observers agree on their order. If one event can influence another, then every observer, regardless of motion, agrees that the cause comes before the effect. The order of causally connected events is absolute, invariant, the same in every frame. Only the order of causally disconnected events, events that can have no influence on one another, is relative and observer-dependent. This is a remarkable piece of cosmic engineering, if one may call it that. The block universe allows the present to be a matter of perspective, allows different observers to disagree wildly about what is happening now across the vast distances of space, and yet it preserves the integrity of cause and effect with perfect reliability. The disagreements are always confined to the region where they can do no harm, where no signal can travel to expose the contradiction. You and a passing observer may disagree about what is currently happening on a distant world, but you can never disagree about the order of events you could both, in principle, observe and be affected by. The structure protects causality by ensuring that the relativity of simultaneity touches only those events forever sealed off from causal contact. The block contains all of time, all events equally real, and yet within it, the lines of cause and effect run in a single consistent direction that no observer can dispute. The light cone structure also reframes what we mean by the future and the past in a way that is more precise and more interesting than the everyday meanings. The everyday future is everything that comes after now, everywhere in the universe. But relativity teaches that this notion is ill-defined, because what comes after now depends on the observer. The light cone offers something better. Your absolute future is your future light cone, the set of events you could possibly influence. Your absolute past is your past light cone, the set of events that could possibly have influenced you. These are observer independent. Every observer agrees on what lies in your future light cone and what lies in your past light cone, because these are defined by the invariant speed of light rather than by any particular plane of simultaneity. The everyday distinction between past and future, universal and sharp, fractures under relativity. But a deeper distinction, defined by causal connectability, survives intact. This is the genuinely meaningful structure of time in the block universe. Not a flowing line, but a nested arrangement of cones, each event sitting at the apex of its own forward and backward cones, embedded in a web of causal possibility. There is a subtlety worth drawing out, because it sharpens the picture considerably. The boundary of the light cone, the surface itself, is traced by light, by anything moving exactly at the cosmic speed limit. For a beam of light, the space-time interval between its emission and its absorption is, in a precise mathematical sense, zero. This leads to an almost vertiginous consequence. From the perspective implied by light itself, no time passes, and no distance is traversed between leaving its source and arriving at its destination. A photon emitted by a distant galaxy and absorbed by your eye, after a journey that we measure as millions of years across millions of light years, experiences, if that word can even be applied, no interval at all. Its emission and its absorption are, along its own path, a single connected event with nothing between them. The vast journey that looks to us like an immense passage of time and space collapses from the photon's own frame into immediacy. This is not a quirk to be dismissed. It is a direct feature of the geometry, and it reinforces how thoroughly the block universe upends the intuitive picture. The flow of time that seems so fundamental to us has no meaning at all for the light that knits the cosmos together. All of this gives the block universe a rich, internal architecture. It is not a featureless slab in which all events float in undifferentiated sameness. It is threaded through with the structure of causality, with every event possessing its forward cone of possible effects and its backward cone of possible causes, and with the order of causally connected events fixed absolutely, while the labeling of distant simultaneous events floats freely. The future is fixed, in the sense that all events exist, but the relationships of influence among them follow the strict and consistent geometry of the cones. And here a striking realization emerges about our own situation within this structure. We sit always at the apex of our own light cones, receiving influences from the past cone, sending influences into the future cone, embedded in a particular location in the block from which the rest of the structure radiates outward in its characteristic pattern. The sense we have of facing an open future and leaving behind a fixed past may be, in part, a reflection of this asymmetry in the cones, of the fact that information flows to us from the backward cone and our actions flow into the forward one. Yet this raises a question that the geometry alone does not answer, a question that has troubled physicists as much as the relativity of simultaneity ever did. If the block universe is symmetric in time at its foundation, if the equations make no fundamental distinction between past and future, then why does our experience of it run so decisively in one direction? And why can a small change in motion let one observer reach across the elsewhere into what another observer would call the distant future? To press that question, it helps to walk through a specific scenario that shows just how easily the planes of simultaneity can tilt, and how ordinary an act it takes to shift the boundary of someone's present across an enormous span of distant time. The scenario that demonstrates this most vividly was devised by the philosopher Roger Penrose, and it has come to be known as the Andromeda paradox, though it is less a paradox than a stark illustration of how strange relativity's treatment of the present truly is. Andromeda is the great spiral galaxy nearest to our own, lying roughly 2.5 million light-years away, so distant that its light takes 2.5 million years to reach us, so distant that it sits firmly in the causally disconnected elsewhere relative to any moment of our lives. Nothing happening in Andromeda now, by any reckoning, can affect us now, and nothing we do now can affect Andromeda for millions of years. It is exactly the kind of remote location where the relativity of simultaneity has room to produce dramatic effects, and Penrose used it to make those effects unmistakable. Imagine two people walking past each other on a street here on Earth. They pass at the same point, at the same instant, brushing shoulders perhaps, as ordinary as any encounter on a sidewalk. One of them is walking in the general direction of Andromeda, and the other is walking in the opposite direction, away from it. Their speeds are nothing remarkable, the speed of an unhurried stroll, a few kilometers per hour. By every standard of daily life, these two people share the same moment. They are at the same place at the same time, and if you asked them what time it is, they would give the same answer. And yet, because of the relativity of simultaneity, their planes of present, extended out across the vast distance to Andromeda, do not coincide. They are tilted relative to one another, and the tilt, amplified by the immense distance, produces a divergence in their respective Andromedan presents of not seconds but days. Work through what this means concretely. For the person walking toward Andromeda, the plane of simultaneity tilts so that their present out at Andromeda includes events that lie some days in the future, compared to the present of the person walking the other way. If, in the history of Andromeda, there were a great fleet preparing to launch an expedition toward Earth, then, for one of the two pedestrians, the one walking toward Andromeda, the decision to launch has already been made. The fleet is already underway. The event is in the fixed past, of their Andromedan present. For the other pedestrian walking away, that same launch has not yet been decided. The deliberation is still ongoing. The future of Andromeda is still open on this matter. Two people passing on a sidewalk, sharing what they would both call the same moment, nonetheless have presents that disagree about whether a momentous event millions of light years away has happened or not. One carries a now in which it is settled history. The other carries a now in which it remains undecided. The force of the example lies in how utterly mundane the difference in their situations is. We are not talking about spaceships traveling near the speed of light, or astronauts returning from relativistic journeys to find the world aged. We are talking about two people walking in opposite directions at walking pace. The effect is real, predicted exactly by relativity, and it follows from nothing more exotic than a difference of a few kilometers per hour, combined with the enormous lever arm of intergalactic distance. The relativity of simultaneity is not reserved for extreme conditions. It is woven into every relative motion, however slight. It is only the smallness of the distances in ordinary life that hides it. Stretch the distance to the scale of galaxies, and the act of turning around to walk the other way redraws the boundary of your present across days of distant history. Now, it is essential to be careful about what this does and does not imply, because the example is easy to misread. The pedestrian walking toward Andromeda cannot actually find out about the fleet's decision. They cannot look up and see the launch, cannot receive any signal confirming it, cannot act on the knowledge in any way. The light from that event will not reach Earth for 2.5 million years, and so the launch remains, for both pedestrians, entirely outside their causal reach, locked in the elsewhere. The disagreement between their presence is real, but it is causally inert. Neither can exploit it. Neither can use their tilted plane of simultaneity to gain information the other lacks. This is exactly the protection that the light cone structure guarantees. The relativity of simultaneity is permitted to make their presence diverge precisely because the divergence concerns events that no signal can deliver. The block universe lets the now be a matter of perspective, only where that perspective can never be tested against a causal fact. And yet, the philosophical sting is not removed by this protection. Penrose drew the lesson sharply. If the fleet's decision is, for one observer, an event in the settled past, then in what sense can it be genuinely undecided for the other? If the event is real and fixed for the pedestrian walking toward Andromeda, real in just the way that any present event is real, then how can the same event be an open question, a not yet, for the pedestrian walking away when the two of them stand at the same point of space and time? The event cannot be both decided and undecided in any absolute sense. The only coherent resolution, Penrose suggested, is that the event is simply there, fixed, part of the block, and that the disagreement is not about whether it has happened, but about how each observer's perspective slices the unchanging structure. The fleet's decision is neither in the past nor in the future, absolutely. It is at its place in the block, and the pedestrians, by their different motions, merely assign it to different positions relative to their own nows. But if the event is fixed in the block, then so is everything that follows from it. So is the fleet's arrival, the consequences on Earth, the entire downstream history. The openness of the future, the sense that the fleet might or might not launch, that the decision is still being weighed, appears to be an artifact of being a particular observer at a particular place, not a feature of reality. This is the deeper point that the Andromeda example is designed to drive home. The relativity of simultaneity, combined with the principle that what is present is real, leads inexorably toward the conclusion that distant events we would naturally regard as future are, for some equally valid observer, already settled past. And since reality cannot sensibly depend on whether one happens to be walking toward or away from a distant galaxy, the events must be settled simply, as part of the block. The example takes the abstract Rietdijk and Putnam argument and gives it a concrete human face, two ordinary people on a street, and shows that the abstract conclusion follows from the most pedestrian of circumstances. The future is not waiting to be created. For someone, somewhere, moving at an ordinary pace, it is already history. It is worth pausing to absorb how this transforms the meaning of the word future. In ordinary usage, the future is what does not yet exist, the realm of possibility, the not yet real. The Andromeda example, and the broader logic of the block, suggests that this usage describes our epistemic situation rather than the structure of reality. The future is what we do not yet know, what lies ahead of us along our particular world line, what our memories do not include. But it is not what does not yet exist. From the standpoint of the block, the future exists exactly as much as the past, fully formed, occupying its definite locations. Our ignorance of it, our inability to remember it, or to receive signals from it, is a fact about our position and our cognitive makeup, not about the reality of those events. The pedestrian walking toward Andromeda has, in a sense, a present that has crept further along the distant galaxy's timeline than the other pedestrian's present, and yet neither has crept past the edge of an existing structure. They have merely angled their slices differently through a loaf that was already whole. Once this is granted, a question that has been gathering force can no longer be deferred. If the future is as real and as fixed as the past, if tomorrow already exists in the block in just the way yesterday does, then we are forced to confront directly what it means to live in such a universe. We must ask what becomes of the difference we feel so powerfully between the settled past and the open future, and whether that difference corresponds to anything real or is purely a matter of our perspective and our knowledge. We have established that the physics points toward a fixed four-dimensional structure. We must now turn to what that structure implies for the most basic features of our experience, beginning with the unsettling prospect that everything that will ever happen to us is, in the most literal sense, already there. To say that the future already exists is to make a claim whose weight is easy to state and difficult to absorb. It means that the events of next week are not waiting to be brought into being. They are already in place, occupying their locations in the block, as definite and as real as the events of last week. The conversation you will have tomorrow has, in this view, already happened, in the sense that it sits at its appointed point in space-time, complete in every detail. The day of your death is somewhere in the structure, fixed, with all its particulars settled. Nothing about it is undetermined, waiting on a roll of the dice or a choice yet to be made. It simply is, as much as any moment you have already lived through is. This is what Eternalism, the philosophical name for the block universe view, asserts in its starkest form. Past, present, and future are all equally real, and the privileged status we grant the present is an illusion of our perspective. It is worth distinguishing this carefully from a related but different idea, because confusion between them muddies the discussion The block universe is not by itself a claim about determinism in the usual sense. Determinism is the thesis that the state of the universe at one time, combined with the laws of nature, fixes the state at all later times, that the present determines the future through the operation of physical law. The block universe is a claim about existence, not about determination. It says the future exists, not necessarily that it is calculable from the present by some deterministic rule. In principle, one could imagine a block universe in which the events, though all equally real and all fixed in place, are not derivable from earlier events by any law, in which there is genuine randomness in how one part of the block relates to another. The fixity of the future in the block picture is the fixity of something that exists, not necessarily the fixity of something forced by prior causes. This distinction will matter greatly when we come to questions of chance and choice. But for now, the key point is simpler. Whether or not the future is determined by the past, the block universe says the future is there, real and complete, regardless of how it came to be what it is. Confronting this, the mind rebels, and it rebels for reasons worth examining rather than dismissing. The strongest source of resistance is the overwhelming sense that the future is open, that what happens next depends on what we do, that the path ahead branches into possibilities among which our choices select. This sense is not a casual impression. It is the foundation of how we deliberate, how we plan, how we hold ourselves and others responsible. When you weigh whether to take one job or another, you experience the two futures as both available, as genuine alternatives, with your decision determining which becomes actual. The block universe seems to say that this is mistaken, that only one of those futures exists, that it was always the one that exists, and that your sense of selecting between live options is a kind of performance enacted at a point in the structure where the outcome is already in place, further along your world line. The deliberation is real, in the sense that it occupies its place in the block and genuinely happens. But the openness it seems to presuppose, the branching of possibilities, may be an appearance generated by our ignorance of which branch we are, in fact, already on. The defender of the block universe has a careful response to this, one that does not simply dismiss the experience of deliberation, but reinterprets its significance. Consider what it would mean for your deliberation to be efficacious within the block. Your weighing of options, your reasoning, your eventual choice, all of these are events along your world line. They are part of the causal structure. The job you end up taking is connected, through the chain of cause and effect running up your world line, to the deliberation that preceded it. In a real and meaningful sense, your choice produces the outcome. The outcome is what it is because your deliberation went the way it did. The fact that all of this is already in place in the block does not erase the causal role of your choosing. It does not make your deliberation a sham, a wheel spinning without engaging the machinery. The block contains the deliberation, the choice, and the consequence, all linked in the proper causal order, and removing the deliberation would, if such a thing could be done, remove the consequence too. Your choosing matters in the sense that the outcome depends on it. What the block denies is only that there was, at the moment of choosing, a genuine fork with two existing branches, one of which, your choice, extinguished. There is one world line, and your choice is the event along it that the outcome flows from. Whether this response is satisfying, is a question that has divided thoughtful people, and we will return to it when we take up free will directly. For now, it is enough to register that the fixity of the future in the block universe does not obviously eliminate the causal efficacy of human action, even if it complicates our intuitive picture of open possibilities. The deeper puzzle the fixed future presents is not, in the first instance, about freedom. It is about why, if all moments are equally real and the structure is fixed and complete, our experience is so radically asymmetric between past and future. We remember the past and not the future. We feel that the past is closed and the future open. We age in one direction and not the other. If the block is just a static four-dimensional structure with no intrinsic flow, no privileged present, no objective direction, then where do all these asymmetries come from? Why does the structure feel so different in its two temporal directions when, at the level of its fundamental description, it is supposed to be just a fixed arrangement of events with no built-in arrow? This is among the most serious challenges the block universe must answer, because the asymmetries are not subtle. They are everywhere, pervasive, defining features of existence. A cup that falls and shatters never spontaneously reassembles. Heat flows from hot to cold, and never the reverse on its own. We are born young and grow old, never the other way. Living things develop, reproduce, and decay in a fixed sequence. The entire texture of experience runs in one direction, and any honest account of time must explain this. If the block universe is correct, the explanation cannot come from time itself flowing in a particular direction, because the block has no flow. The explanation must come from something within the structure, some feature of how events are arranged that produces the appearance of direction without any genuine flow underlying it. And remarkably, physics has identified a strong candidate for exactly this, a feature of the universe that points in one temporal direction, even though the underlying laws do not. That feature is the relentless increase of disorder, the quantity physicists call entropy, and understanding how it manufactures the arrow of time within a directionless block is essential to making the whole picture coherent. But before turning to entropy, it is worth holding on to the strangeness of where the reasoning has brought us, because the block universe asks for a genuine reorientation of how we think about our own lives. In the ordinary picture, your life is a process, a becoming, a continual bringing into existence of new moments out of the raw material of possibility, with the past accumulating behind you and the future perpetually fresh and unmade ahead. In the block picture, your life is more like an object than a process. It is a fixed shape in space-time, a world line of immense complexity, every part of it equally existent, from the first cell that was you to the last breath you will take. You do not move through this shape. The sense of moving through it is, as we discussed, the way each point along the shape experiences itself, equipped with memories of the earlier points. But the shape itself does not change, does not grow, does not get used up. It is complete. In a sense that the block universe makes precise, you have always existed and will always exist, not in the sense of living forever, but in the sense that your existence is a permanent feature of the four-dimensional structure, never created and never destroyed, only located within a particular span of the time dimension. The moment of your death does not annihilate you. It is simply the far boundary of your world line, no more an erasure of your existence than the southern edge of a continent is an erasure of the land. The land does not stop existing south of its border. It simply does not extend there. And you do not stop existing after your final moment. Your world line simply does not extend past it, while remaining eternally real along its full length. This is a strange consolation, and we will see later that Einstein himself seems to have drawn something like comfort from it. But it sits uneasily alongside the vivid, undeniable feeling that time is slipping away, that moments are being lost forever, that the past is gone. To reconcile the static eternal block with the felt loss and flow of lived time, we need to understand why the structure presents itself to us so insistently as a one-way passage. We need to understand the origin of time's arrow, and that means turning to the one law of physics that alone among the fundamental laws knows the difference between the past and the future. Among all the laws of physics, there is a peculiar asymmetry that becomes obvious only when you look for it. Nearly every fundamental law treats the two directions of time identically. Take the equations governing the motion of particles under gravity, or the behavior of electric and magnetic fields, or the rules of quantum mechanics, and you find that they work equally well run forward or backward. If you filmed a planet orbiting a star and played the film in reverse, nothing in the laws of physics would be violated. The reversed orbit is just as valid a solution to the equations as the forward one. The same holds for two billiard balls colliding on a frictionless table. Film the collision, reverse it, and the reversed version looks perfectly physical, obeying every law of motion. At the level of fundamental dynamics, the laws are blind to the direction of time. They contain no preference for past over future, no built-in arrow. Physicists call this property time reversal symmetry, and it holds with only the most subtle and rare exceptions throughout the foundational laws of nature. Yet the world we experience is overwhelmingly asymmetric. Film an egg falling from a counter and smashing on the floor, then play it backward, and the reversal is absurd. Shattered fragments do not leap from the floor, reassemble into a whole egg, and rise to land gently on the counter. We have never seen it happen, and never will. Film smoke rising from a fire and dispersing into the air, reverse it, and we see dispersed smoke gathering itself from across a room and funneling neatly back into a coherent plume, which never occurs. Film cream stirred into coffee, reverse it, and we watch the uniform brown liquid spontaneously separate into white cream and dark coffee, which never happens. Everywhere we look, the macroscopic world has a clear and unmistakable direction. Things fall apart, mix together, spread out, wind down. The future looks reliably different from the past. So we face a genuine puzzle. If the underlying laws have no preferred direction, where does the obvious directionality of experience come from? How can time-symmetric laws give rise to a world so thoroughly time-asymmetric? The answer, worked out over the course of the 19th century and refined ever since, lies in the concept of entropy and the statistical behavior of systems made of enormous numbers of parts. Entropy is, roughly, a measure of disorder, but a more precise way to think of it is as a measure of how many different microscopic arrangements of a system's parts would look the same at the macroscopic level. Consider the egg. An intact egg is a highly ordered arrangement. The shell is whole, the yolk and white are in their proper places. Everything is structured. There are relatively few ways to arrange the molecules of an egg that count as an intact egg sitting on a counter. But a smashed egg spread across the floor. is a disordered arrangement, and there are astronomically many ways to splatter those same molecules across the floor that all count as a smashed egg. The smashed state is not special. It is generic. Almost any way of scattering the pieces gives you a mess that looks like a smashed egg, while only very particular arrangements give you an intact one. This difference in the number of arrangements is the key. When a system can be in any of its possible microscopic states, and when there are vastly more disordered states than ordered ones, then a system left to itself will, with overwhelming probability, end up in a disordered state, simply because there are so many more of them. It is not that disorder is forced by any law. It is that disorder is by far the most likely outcome, in the same way that shuffling a deck of cards is overwhelmingly likely to produce a disordered sequence rather than a perfectly sorted one. There is nothing in the laws of card shuffling that forbids the deck from coming out in perfect order. It is simply that out of the enormous number of possible orderings, only one is the sorted sequence, and countless others are disordered. So a random shuffle almost never produces order. Entropy is the physicist's way of counting these possibilities, and the second law of thermodynamics, the law that says entropy tends to increase, is at bottom a statement about probability. Systems evolve from less probable, more ordered states toward more probable, more disordered ones, not because a law commands it, but because the disordered states are so vastly more numerous that ending up in one is nearly certain. This statistical increase of entropy gives us a direction in time, even though the underlying laws are symmetric. The direction in which entropy increases is the direction we call the future. The past is the direction of lower entropy, of greater order. This is why the egg smashes but never reassembles. The smashing increases entropy, moving from the ordered intact state to the disordered splattered state, and this is overwhelmingly probable. The reassembly would decrease entropy, moving from disorder to order, and this is so improbable as to be effectively impossible, not forbidden by any law, but ruled out by the staggering odds against it. The arrow of time, in this account, is the arrow of increasing entropy. It is not a feature of time itself, but a feature of how the matter in the universe is arranged and how it evolves statistically. And crucially, this is entirely compatible with the block universe. The block does not need to flow in order to contain an arrow. The arrow is built into the static structure as a gradient, a direction along the time dimension in which entropy is higher at one end and lower at the other. Just as a mountain range has a definite up and down, even though the mountains are not moving, the block has a definite past and future direction, even though it is not flowing, because entropy is low toward one temporal end and high toward the other. But this only pushes the question back one step to a deeper and more profound puzzle. If the increase of entropy explains the arrow of time, then we must ask why entropy was ever low to begin with. The statistical argument says that systems move from order to disorder because disorder is more probable. But for there to be any increase at all, the universe must have started in a state of extraordinarily low entropy, a state of exquisite order, far more ordered than anything we see today. If the universe had begun in a high entropy, disordered state, there would be no room for entropy to increase, and there would be no arrow of time at all. The fact that entropy is increasing now means it was lower in the past, which means it was lower still further back, which traces all the way to the beginning, to the earliest moments after the origin of the cosmos, where entropy must have been astonishingly, almost inconceivably low. This is one of the great unsolved questions of physics. Why did the universe begin in such a special, highly ordered, low entropy state? Nothing in the known laws requires it. A high entropy beginning would have been vastly more probable in the same statistical sense that governs the egg. Yet the universe began in a state of profound order, and it is the slow unwinding of that initial order, the gradual increase of entropy from that remarkably low starting point, that gives time its direction throughout all of cosmic history. The depth of this puzzle is hard to overstate. The arrow of time that we experience in every shattering cup and every cooling coffee, in every memory of the past and every aging of the body, traces back ultimately to the peculiar low entropy condition of the early universe. The reason you remember yesterday but not tomorrow, the reason the past seems fixed and the future open, the reason effects follow causes and not the other way around, all of it rests on the fact that the universe started in a state of extraordinary order and has been growing more disordered ever since. Memory itself is a low entropy record, an ordered trace left by the past, and the capacity to form such records depends on the entropy gradient. We can have records of the past because the past was more ordered, providing the low entropy conditions in which stable records can form. We cannot have records of the future because the future is the high entropy direction, and the conditions for forming records run the wrong way. The asymmetry of memory, which is one of the most basic features distinguishing past from future in our experience, is itself a consequence of the entropy gradient established by the universe's ordered beginning. So the block universe accommodates the arrow of time without requiring time to flow. The arrow is a feature of the contents and arrangement of the block, specifically the entropy gradient running from the low entropy early universe toward the high entropy future, and not a feature of any movement through the block. Within this static structure, the direction of increasing entropy is the direction we call later, and all the asymmetries of experience, the asymmetry of memory, of cause and effect, of growth and decay, align themselves with this gradient. The flow we feel is, on this account, our way of registering our position within the entropy gradient, the fact that we are part of a vast process of increasing disorder that runs consistently in one direction. We do not need a moving present to explain why time seems to go forward. We need only the gradient and a being like ourselves embedded within it, forming memories in the low entropy direction and facing uncertainty in the high entropy direction. Yet even granting all this, a stubborn intuition persists, the conviction that the future is genuinely different from the past, not merely in its entropy, but in its very reality, that the past is fixed and done, while the future remains genuinely unmade and open. This intuition has given rise to a serious rival to the block universe, a model that tries to take the openness of the future seriously while still respecting the lessons of physics, and it deserves a careful hearing before we judge whether the block truly captures the structure of time. The rival model is called the growing block universe, and it represents an attempt to occupy a middle ground between the static eternalism of the full block and the fleeting reality of pure presentism. Its central idea is intuitively appealing. The past and the present are real, fully existent, fixed and settled, exactly as the block universe says. But the future is not. The future does not yet exist. Reality in that picture is a block that grows. As each new moment comes into being, it is added to the leading edge of the block, accreting onto the accumulated past, like new layers of rock laid down over geological time. The present is the growing surface, the frontier, where new reality is constantly being created and added to the existing structure. Behind this surface lies the vast, fixed, real past. Ahead of it lies nothing, not yet. Only the potential for moments that have not been created. The block grows moment by moment, and the present is the edge of becoming, the place where the not yet real crosses over into the permanently real. The appeal of this model is considerable, because it seems to capture something the full block universe denies. It preserves the openness of the future. Tomorrow does not exist yet, so it is genuinely unmade, genuinely open, genuinely subject to determination by what happens at the present edge. It preserves the sense that the present is special, that now is the place where reality is actively happening, where the action is, where existence is being forged. It accommodates the deep intuition that there is a real difference between the settled past and the unmade future, that this difference is not merely a matter of our knowledge or perspective, but is built into the structure of reality itself. And it keeps the past fixed and real, accounting for the determinacy of history, the fact that what has happened cannot be changed and is fully definite. In many ways, the growing block seems to give us the best of both worlds, the reality and fixity of the past, combined with the openness and potentiality of the future, with the present as the dynamic boundary between them. The model has serious philosophical defenders, and it has been developed with considerable sophistication. But it faces a battery of objections, some of which strike at its very coherence, and the most damaging of these come, once again, from relativity. The growing block requires a privileged present, an objective now that constitutes the growing edge of reality. The whole picture depends on there being a definite observer-independent surface, where the past meets the not yet existent future, a surface that is the same for everyone, the universal frontier of becoming. But this is precisely what relativity denies. We have seen at length that there is no universal present in relativity, no observer-independent plane of simultaneity, no single now that sweeps across all of space. Different observers slice space-time at different angles, and there is no fact about which slice is the true present. If the growing edge of the block is supposed to be the objective present, then relativity tells us no such objective present exists. The edge would have to be at a different place for different observers, which makes no sense if the edge is the boundary between existence and non-existence. An event cannot exist for one observer and not exist for another moving differently, when existence is supposed to be the absolute matter of whether something is part of reality at all. This objection is severe, and it parallels the difficulty that the Rietdijk and Putnam argument raised for presentism. If the future does not exist and the past does, then there must be a determinate fact about which events are past, which are present, and which are future. A fact that draws the boundary of the growing block. But relativity says this boundary is observer-dependent, that what one observer calls present another calls past or future, with no privileged answer. The growing block seems to require exactly the kind of absolute simultaneity that relativity has dismantled. To save the model, one would have to reintroduce a preferred frame, a cosmic standard of rest against which the true present is defined, contradicting the fundamental relativistic principle that no frame is privileged. Some defenders of the growing block are willing to bite this bullet, proposing that there really is a preferred frame, perhaps tied to the large-scale structure of the universe, and that relativity's denial of preferred frames is a feature of the local laws rather than a deep truth about reality. This is a coherent position, but it pays a high price, setting itself against the spirit and arguably the substance of the most successful theory of space and time we possess. There is a second objection to the growing block that is more abstract but equally penetrating, and it concerns how anyone could ever know they are located at the growing edge. In the growing block, the past is fully real, which means that all the past moments exist, with all their contents, including all the people who lived in those moments, with their brains and their thoughts and their sense of being present. The version of you that existed yesterday is, in the growing block, just as real as the version of you that exists now. That past version had a vivid sense of being present, of being at the growing edge, of being where reality was actively happening. But that past version was not at the growing edge, or rather, it was at the edge when it was the edge. But the edge has since moved on, leaving that version behind in the fixed past, while still fully real. So here is the difficulty. If past versions of you are equally real and equally convinced of being present, then your present conviction of being at the growing edge is no evidence that you actually are. You might be a past moment, fully real, falsely believing yourself to be at the leading edge, when in fact the edge has long since moved beyond you. Every moment in the growing block believes itself to be the present, and most of them are wrong. By what right do you assume you are the lucky one actually located at the edge? The growing block, in trying to give the present a special status, ends up unable to explain why your present should be that special one, rather than one of the countless past moments that are equally real and equally deluded about their status. This objection is subtle but devastating, because it shows that the growing block, despite its intention to privilege the present, cannot actually deliver a present that you can know yourself to occupy. And if you cannot know whether you are at the edge or buried in the fixed past, then the supposed difference between the edge and the interior does no work. The growing block collapses under this pressure toward the full block universe, in which all moments are equally real and equally convinced of their presentness, with none of them objectively privileged. The very feature that was supposed to distinguish the growing block from the static block, the special reality of the present edge, turns out to be undetectable and inert, leaving us with a structure that behaves for all purposes like the full block after all. The growing block also struggles with a problem about the past that mirrors its problem about the future. If new moments are constantly being added to the block, then the block is constantly getting larger, which means the total amount of reality is increasing. But increasing with respect to what? Growth is a process in time. To say the block grows is to say it is smaller at earlier times and larger at later times. But the times in question are the very times that make up the block. The block cannot grow within its own time dimension, because that dimension is part of what is growing. To make sense of the block growing, one seems to need a second time, an external time with respect to which the block's growth occurs, a meta-time in which the present edge advances. But this second time is mysterious, unexplained, and itself subject to the same questions. Does it flow? With respect to what? The growing block, in trying to capture the flow of time, seems to require a flow of time outside the block to govern the block's growth. And this regress is a sign that something has gone wrong. The full block universe avoids this entirely by denying that the block grows at all. It simply is, in its full four-dimensional extent, with no external time and no growth. And the appearance of growth is, like the appearance of flow, an artifact of our position within the structure. For all these difficulties, the growing block universe remains a live option in the philosophy of time, defended by serious thinkers who judge that the price of saving the openness of the future is worth paying. It captures something that the full block seems to lose, the sense that the future is genuinely unmade, that reality is dynamic, that the present is where existence happens. Whether that something is a real feature of the world, or merely a deep feature of human psychology, is exactly the question at issue. The growing block insists it is real and pays the cost in tension with relativity and in the puzzles about the edge and the meta-time. The full block insists it is illusory and pays the cost in the deep counterintuitiveness of a future that already exists. Between these stands the oldest and most stubborn intuition of all, the one that refuses both blocks and insists that only the present is real, that the past is gone and the future is not yet, and that reality is nothing but the fleeting now. This is the view that almost every human being holds before they think about it carefully. And despite the formidable obstacles relativity places in its path, it has not surrendered. It deserves to be examined on its own terms, both for the intuition it preserves and for the difficulties that finally make it so hard to maintain. Presentism is the view that only the present is real. The past was real, but is no longer. The future will be real, but is not yet. At any moment, the sum total of what exists is what exists now, the present configuration of the world, and nothing else. Yesterday is not a place that still exists somewhere, fixed and accessible in principle. It is simply gone, vanished, retained only in memories and records that are themselves present things. Tomorrow is not a place waiting up ahead. It is nothing at all, mere potential, not yet brought into being. Reality is the present, and only the present, a single advancing instant. And as it advances, the old present ceases to exist, and a new present takes its place. This is the metaphysics implicit in ordinary speech and ordinary thought, the framework so natural that articulating it feels almost like stating a tautology. Of course, only the present is real. What else could be real? The past is over. The future has not happened. To exist is to exist now. The strength of presentism is that it matches experience perfectly. We never encounter the past or the future directly. We only ever encounter the present. Every observation we make, every thought we have, every action we take, occurs now. The past comes to us only through present traces, memories in our brains, marks on paper, light arriving from distant events. The future comes to us only through present anticipations, predictions, plans, expectations. We have no direct contact with any time but this one. Presentism takes this feature of experience and elevates it to a claim about reality. The only time we ever encounter is the present. And so, presentism says, the present is the only time that exists. This has an undeniable elegance and economy. It does not posit the existence of vast reaches of past and future that we can never observe. It does not require a four-dimensional block stuffed with events we cannot reach. It says, reality is exactly as large as what is happening now, and not one moment larger. Presentism also seems to capture the openness of the future and the fixity of the past more cleanly than any other view. The past is fixed because it is gone, settled, no longer subject to alteration. The future is open because it does not yet exist, because it is genuinely undetermined, waiting to be brought into being by the unfolding present. The flow of time is not an illusion in this picture, but the most basic fact of all, the continual coming into being of new presents and passing away of old ones. The present moves, reality is renewed instant by instant, and the deep human sense that time passes and that now is special is vindicated as a direct perception of the way things are. Where the block universe must explain away the flow of time as an artifact of perspective, presentism takes it at face value as the fundamental dynamic of reality. For these reasons, presentism is the default view, the one we all start with, the one that requires no argument to make it seem obvious. And yet, when presentism is examined closely, especially in light of relativity, it runs into difficulties that have proven extremely hard to overcome. The first and most serious, as we have already seen, comes from the relativity of simultaneity. Presentism requires a definite, objective present, a fact about which events are happening now. The entire view rests on the present being a real, well-defined thing, the totality of what exists. But relativity says there is no objective present, no observer-independent fact about which distant events are simultaneous with this moment. The present in relativity is relative to motion, different for differently moving observers, with no privileged answer. If presentism says reality consists of what exists now, and relativity says there is no objective now, then presentism faces a crisis. Reality cannot consist of the present if there is no determinate present to consist of. Either presentism must reject relativity, insisting on a preferred frame that defines the true present against all the evidence that no frame is privileged, or it must somehow relativize existence itself, allowing that what is real differs from observer to observer, which seems to abandon the very idea of a single shared reality that presentism was meant to capture. Neither option is comfortable. The first sets presentism against the best confirmed theory of space and time. The second dissolves the unified reality that gave presentism its appeal. The second major difficulty for presentism concerns how it can account for the truth of statements about the past and future. We say true things about the past all the time. It is true that a great war occurred in the past century. True that you were born on a particular day. True that civilizations rose and fell. These statements are true, and their truth seems to depend on the past being a certain way. But if the past does not exist, if it is simply gone, then what makes these statements true? There is no past event for them to correspond to, because the past event no longer exists. Presentism must find something in the present that makes past tense statements true, some present trace or fact that grounds the truth of claims about a past that no longer exists. This is the problem of grounding past truths, and presentists have labored to solve it, proposing that the present world contains within it all the traces and tendencies needed to ground truths about the past. But the solutions are intricate and contested, and many find them less satisfying than the simple answer the block universe gives, which is that past statements are true because the past events are simply there, real, part of the structure, available to make statements about them true, in exactly the way present events make present statements true. The block universe grounds the truth of claims about other times effortlessly by granting that those times exist. Presentism must do extra work to explain how claims about non-existent times can be true, and the difficulty of that work counts against it. There is a further subtlety that sharpens the relativistic objection in a particularly vivid way. Consider the consequences of presentism combined with the relativity of simultaneity for the question of what exists. Suppose you and a friend are sitting together, at rest relative to one another, and your planes of present coincide. You agree about what is happening now, including what is happening at distant locations. Now your friend stands up and begins to walk. The moment they start moving, their plane of simultaneity tilts, and their present, out at distant locations, now includes different events than yours. If presentism is true, and reality is what exists in the present, then the act of your friend standing up and walking has changed what reality consists of for them, sweeping their present across distant regions to include events that, for you, sitting still, are future or past. But you are sitting right next to them. You share the same location. How can reality itself, the totality of what exists, differ between two people sitting next to each other merely because one of them stood up? Existence is not the kind of thing that should depend on whether one is sitting or walking. This is the relativity of simultaneity, pressing directly on the presentist notion of existence, and it shows how deeply the two are in tension. The block universe avoids the problem by saying that all the events exist regardless, and that standing up merely changes which events one labels as present, not which events are real. Presentism cannot take this escape, because for presentism, being present and being real are the same thing. So, a change in what is present is a change in what is real, which leads to the absurdity of reality, depending on one's gait. Faced with these difficulties, defenders of presentism have developed increasingly sophisticated responses, and the debate is far from settled. Some argue that the relativity of simultaneity, while true as a claim about measurement and observation, does not settle questions about existence, and that there might be a real present that is simply not detectable by physical means, a metaphysical present that exists even though physics provides no way to single it out. This preserves presentism at the cost of positing a present that does no physical work and leaves no physical trace, which critics find unacceptably ad hoc. Others embrace a relativized notion of existence, accepting that what is real is relative to a frame of reference, and developing careful logical frameworks to keep this from collapsing into contradiction. Still, others argue that the very notion of existence at issue in these debates is confused, that the dispute between presentism and eternalism is merely verbal, a disagreement about how to use the word exists, rather than a substantive disagreement about the world. This deflationary position holds that once we are clear about what we mean, the apparent conflict dissolves, and that both the presentist and the eternalist are describing the same physical facts in different vocabularies. Whether this is right, or whether there is a genuine substantive question about which of the models correctly describes reality, is itself a matter of ongoing dispute among philosophers of time. What emerges from all this is that presentism, the most natural and intuitive view of time, is also the view that sits least comfortably with modern physics. It captures our experience beautifully and our metaphysics poorly, at least if we take relativity as a guide to metaphysics. The block universe captures the physics beautifully and our experience poorly, demanding that we treat the flow of time and the openness of the future as illusions. The growing block tries to split the difference and inherits problems from both directions. None of the three is free of difficulty, and reasonable, informed thinkers continue to disagree about which is correct, or whether the question even has a determinate answer. But the weight of physical evidence, the relativity of simultaneity above all, presses persistently toward the block, toward the conclusion that all moments are equally real, and the flowing present is a feature of perspective rather than reality. And if that conclusion is accepted, it forces upon us one of the most disquieting questions a human being can face, a question that presentism's open future was designed to keep at bay. If the future already exists, fixed and complete, then what becomes of our freedom to shape it? If tomorrow is already there, in what sense can we be said to choose it? This is the question of free will in a block universe, and it cannot be avoided any longer. If every moment of your life already exists, fixed in place within the block, then the choice you will make an hour from now is already there, settled, occupying its position in the structure. You will deliberate, you will weigh your options, and you will decide. But the outcome of that deliberation is, in the block picture, already a fact about a region of spacetime slightly further along your world line than the region you currently occupy. This seems to threaten the very notion of free will. We ordinarily think of a free choice as one that is genuinely open at the moment of choosing, one where more than one outcome is really possible, where the future hangs in the balance, and our decision tips it one way rather than another. But if the future is already there, then it seems there is only one outcome, the one that exists, and our sense of open possibility is an illusion. The choice was, in a sense, always going to go the way it goes, because the way it goes is simply a feature of the unchanging block. How can we be free if the future is already written? This is one of the oldest and most difficult questions in philosophy, and it is essential to approach it carefully, because the block universe's relationship to free will is more subtle than it first appears. The first thing to notice is that the threat the block poses to free will is not obviously different from the threat posed by ordinary determinism, which is a question that long predates relativity and the block universe. Determinism is the thesis that the state of the universe at any moment, together with the laws of nature, fixes the entire future. If determinism is true, then given the way things are now, only one future is physically possible, the one the laws dictate. Philosophers have debated for centuries whether free will is compatible with determinism, and the debate has produced two broad camps. The incompatibilists hold that free will requires genuine openness, the ability to have done otherwise in a strong sense, and that determinism, by fixing the future, destroys this and therefore destroys free will. The compatibilists hold that free will, properly understood, does not require this kind of openness at all, and that we can be free even in a determined world, provided our actions flow from our own desires, reasoning, and character in the right way. The block universe sharpens this ancient debate, but does not fundamentally change its terms. Whether or not the block is deterministic, the block presents the future as fixed in the sense of already existing. The incompatibilist will say, this is fatal to free will. If my future choice already exists, then I cannot do otherwise, because doing otherwise would require the existing future to be different than it is, which is impossible. The choice that exists in the block is the only choice I will make, and so my sense of being able to choose differently is an illusion. There is only one world line, mine, and every event along it, including every choice, is simply there, unalterable, because it is what it is. From this perspective, The block universe is the ultimate vindication of fatalism, the view that what will be, that the future is fixed and our struggles against it are futile, because the outcome is already settled, regardless of what we do. But the compatibilist offers a powerful response, and it is worth following carefully, because it dissolves much of the apparent threat. The fatalist conclusion that our struggles are futile because the outcome is already settled contains a subtle error. It treats the fixed outcome as if it were fixed independently of our choices, as if the future would be the same no matter what we decided, so that our deciding makes no difference. But this is not what the block universe says. In the block, your choice is part of the causal structure that leads to the outcome. The outcome is what it is precisely because your deliberation went the way it did. Your choosing is not bypassed or rendered irrelevant by the fixity of the future. On the contrary, your choosing is one of the things that makes the future what it is. The future is fixed, yes, but it is fixed partly by your choices, which are themselves fixed features of the block, occupying their place in the causal web. To say the outcome is settled regardless of what you do is simply false. The outcome is settled, but not regardless of what you do. It is settled in a way that depends on what you do, because what you do is part of what settles it. This distinction is crucial and easy to miss. Fatalism says the end is fixed, and your actions are irrelevant to it, like a passenger on a train who can walk forward or backward in the carriage, but will arrive at the same destination regardless. The block universe says something quite different. It says the entire journey, including all your actions and their effects, is fixed. But your actions are not irrelevant to where you end up. They are part of the causal chain that determines where you end up. If you had deliberated differently, the outcome would have been different, and the block would have contained a different world line. The fact that the block contains the world line it actually contains, rather than some other one, is partly due to the fact that your deliberations went as they did. Your agency is not erased by the block. It is contained within it as a real causal factor in the unfolding of events. The compatibilist concludes that this is all the freedom we ever really wanted or needed. To be free is for your actions to flow from your own reasoning and character, and to be effective in producing outcomes, and all of this is perfectly possible in the block. What is not possible is for there to be genuine branching, multiple existing futures among which you select. But the compatibilist argues that this kind of branching was never what free will required, and that the demand for it rests on a confused picture of what choice involves. The incompatibilist is not satisfied by this, and the disagreement runs deep. The incompatibilist insists that genuine freedom requires that, at the moment of choice, more than one future be really available, that you could truly have done otherwise. Not merely in the sense that you would have done otherwise if you had wanted to, but in the sense that the world was genuinely open, and your choice was the thing that closed it. The block universe denies this openness. There is one future, the one that exists, and you could not have done otherwise in the strong sense, because doing otherwise would mean the block being different than it is. For the incompatibilist, this is a real loss, a genuine diminishment of the human condition, even if our actions remain causally effective. We are not authors of an open future, but performers of a script already written, even if we are the ones who, in some sense, wrote it by being who we are. There is a further wrinkle that quantum mechanics introduces, and it is often misunderstood, so it bears clarifying. Many people, on first learning that the future is fixed in the block, reach for quantum indeterminacy as a rescue. Quantum mechanics, they note, seems to introduce genuine randomness into the world, outcomes that are not determined by prior states, but occur with mere probabilities. Surely, they think, this openness at the quantum level preserves an open future and saves free will from the fixity of the block. But this hope rests on a confusion. First, randomness is not freedom. If your choices were the product of random quantum events in your brain, they would be no more free than if they were determined by prior causes. A choice that happens randomly is not a choice you control. It is just noise. Adding randomness to the picture does not give you authorship of your actions. It gives you actions that are partly the product of chance, which is not what anyone means by free will. Second, and more fundamentally, the relationship between quantum mechanics and the block universe is itself deeply unsettled, and it is not at all clear that quantum indeterminacy implies an open future in the relevant sense. The interpretation of quantum mechanics, the question of what its probabilities and its measurements really mean for the structure of reality, is one of the most contested areas in all of physics, and it bears directly on whether the smooth, fixed block survives or must be revised. This is a question we cannot postpone any longer, because the block universe we have described emerged from relativity, and relativity is not the only pillar of modern physics. The other pillar, quantum mechanics, tells a story about time that does not obviously fit the block, and reconciling the two is among the deepest unsolved problems we face.